Press tool, die and punch clearance. Introduction. In sheet metal cutting operations such as blanking and piercing, die and punch clearance is the intentional gap between the punch and die. This clearance is critical for clean cutting, tool life, dimensional accuracy, and burr control. Importance of clearance. Proper clearance leads to reduced tool wear, accurate part dimensions, lower cutting force. Insufficient clearance causes excessive burrs, tool breakage, high cutting force. Excessive clearance causes tapered, bent cut edges, poor edge finish, distorted components. Engineering basis for clearance. Clearance is calculated as a percentage of material thickness, T, and depends on the type of material. Formula. Clearance, C equals T times clearance percentage. For mild steel, 5 to 10% of sheet thickness. For aluminum, 4 to 6%. For stainless steel, 8 to 12%. Clearance is divided equally on both sides of the punch. Total clearance is between die and punch. Die, opening, equal punch size, plus total clearance. Example calculation. Given, material equals mild steel, thickness, T, equals 2 millimeters. Clearance percent equals 8%, typical for mild steel. Operation equals blanking, punch size equals 20 millimeter, desired blank size. Total clearance C equals 2 millimeter times 8,100, 0.16. Millimeter clearance per side equals 0.162 equals 0.08. Die size for blanking equals 20, punch plus 0.16 equals 20.16. In blanking, punch defines the blank size, so the die must be slightly larger. Blanking versus piercing. Clearance is operation, blanking, punch size, equal to part, die size, punch plus clearance. Note, blank size equals punch size. Piercing, punch size, punch clearance. Die size equal to hole. Note, hole size equals die opening. Effect of incorrect clearance. Clearance, too small. Effect on cut edge, burnishing dominates, rough edge. Result, high force, punch die damage. Clearance, optimal clean break, slight rollover. Result, smooth edge, minimal burr. Clearance too large. Effect on cut edge, breakage before shearing. Result, large burrs, tapered edges, deformation. Reference table, recommended clearance percent. Material type, recommended clearance percent. Mild steel, 6 to 10%. Stainless steel, 8 to 12%. Aluminum, 4 to 6%. Brass, 6 to 8%. Copper, 4 to 6%. Conclusion. Proper die and punch clearance is essential for high-quality cutting operations. It should be selected based on material type and thickness to optimize tool life, reduce cutting force, and produce burr-free components. It's a techno presentation,